Okay, today we are going to do the final video for Unit 1. And this is, again, involving some work with inverse functions. We are going to graph some of them, but I also want to visit a definition of inverse functions. So if you guys could copy down that definition there at the top, I'll give you a few minutes to do that. Okay, now this composition of f of g of x and g of f of x, okay, those are the two given functions. If they both simplify to equal x, it kind of proves or verifies that the two functions are inverses to each other. So when you hear definition of inverse functions, that's kind of the process that you want to follow to figure out if they're inverses or not. So we're going to do a couple down here. This is kind of the algebraic way to prove that two functions are inverses, or disprove if they're not inverses. So I kind of put on the side, this is algebraically how you would do it. So you're going to start out with two functions. So I've got f and g. I'm going to perform the two compositions. So that would have been the f of g of x and the g of f of x. And I'm going to kind of look at what it simplifies to be and then make my decision based on that. So if I do f of g of x, so I'll do that one right here, that means I'm going to take function g, which is the x plus 4 over 2, and I'm going to plug it in to function f in place of x. So it's going to look like this. So 2 parentheses. Now I'm going to put in this entire function g, and then subtract the 4. Okay, and I'm going to simplify. Now since I've got this big fraction in the parentheses, I'm going to go ahead and cancel the 2's. Those cancel out, they kind of cross cancel. That leaves x plus 4 minus 4. Then I can cancel the 4's, and that just leaves x. Okay, now that's what we wanted it to simplify to, but I have to prove that the second one, the g of f of x, also simplifies to be x. So now I'm going to do that composition. So now I'm going to take function f and I'm going to plug it into function g where the x is. So I'm going to start right now. I'm going to take out that x and I'm going to put in the 2x minus 4. Okay, then I have the plus 4, and that's all over 2. Now this one simplifies a little bit differently. I can do the negative 4 plus 4, I can cancel those. So I get 2x over 2, and then I can cancel the 2's, and I just get x. So are these two functions inverses to one another? Yes. Yes, they are inverses. Okay, now let's try the second one. I'm going to do kind of the same process. I'm going to do f of g of x first. And it doesn't really matter. You can do g of f of x first if you want to. So I'm going to take function g, which is the x plus 3, and I'm going to plug it into function f in place of the x. So I'm going to keep this negative right there. So I'm going to put that g function in parentheses. So when I plug in this x plus 3, I'm going to group it. And then I've got a minus 3 still. Okay, now the negative I'm going to distribute. I really can't do anything else with it. So I'm going to distribute the negative through. And I'm going to simplify this, and it ends up being negative x minus 6. Now, if that happens, on your first composition, that doesn't equal x, like these two did, then you know right away that these two are not inverses to one another. So you can stop there. You don't have to do the g of f of x and just say, no, that spoils it. Not inverses. We can say does not simplify to x. Okay, now we're going to do some graphically. We're going to look at inverses on a graph, which we haven't looked at any graphs yet. So I marked this one graphically. So go ahead and copy down the directions there. I've already got my two equations written down, and then I've got a table for each, a table for the original function and a table for the inverse, and then we're going to use the points in the table to make our graph. Okay, so let's go ahead and start filling out this first table. So this is my function. So we can just use maybe negative 1, 0, and 1. It doesn't really matter. 2, you can throw 2 in there. So if I plug a negative 1 in for x, that's negative 3 minus 2 is negative 5. 0 plugged in is negative 2. 1 and 4. Okay, now we talked earlier when I went through the lesson on finding the inverses. We said all we did was switch x and y. So that's all we're doing. Once we get our table for the original, we're just going to switch the entire table. So all of your x's become the y's. This is the inverse now. And all your y's become the x. Okay, so now I'm going to plot each table, if I have room here. So negative 1, negative 5 will be down here somewhere. Okay, so there's our first line. And then I'm going to graph the inverse. Negative 5, negative 1 is going to be kind of in my mess over here, so I'm going to start with negative 2, 0, 1, 1, and 4, 2. Oops, I'm off track a little bit. There we go. Yeah, straight edges are helpful when your points are spread out. Now, I do want to show, because yeah, we've got the graphs. Most likely they're inverses, unless we messed up our switcheroo here. The line of symmetry is y equals x. Okay, that's the line of symmetry if two functions are inverses to each other. So the line y equals x just goes up like this. I'm going to use a dashed line to show it. And you can tell that kind of, splits those two lines into its symmetry. But, up here we did algebraically how we simplified it to be x. Well, on a graph, you have to be able to show that your line of symmetry is the line y equals x. And we'll mark that down here, line of symmetry. Okay, let's try one more graph, and then we'll wrap it up for Unit 1. So I'm going to do the same thing. I'm going to take this second function, 1/2 x plus 3, and I'm going to generate some points for my table. Clean that up a little. So let's use -1. Actually, you know what? Since we have that fraction in there, I want those to work out to be whole numbers. So if I use -2, 0, 2, and 4, that'll simplify to a nice clean number. So I'm going to take a -2, plug it in for x. Okay, that's going to be -1 plus 3 is 2. 0 in there would be 3. 2 is going to be 4, and 4 is going to be 5. Okay, so that's my original function. Now to get my inverse points, I'm just going to flip x and y. They're going to trade places. Okay, now I'm going to graph them both on my coordinate plane. -2, 2. Okay, that's enough for that one. Then I'm going to graph the inverse. So 2, -2. Okay, then I'm going to show my line of symmetry at the with the equation y equals x. So that would just go up through the origin, slope of 1. I'm going to use a dashed line. And there's your line of symmetry. Which again proves that two lines, or two functions, are inverses to one another graphically. All right, have a great day.